Today we're going to jump into the chapter on probability and combinatorics, and let's start off by talking a little bit about combinations and what that actually means. What a combination basically is, it's a number of different possible arrangements of objects where order doesn't matter. And when we start talking about probability and any kind of combinatorics, we talk about events. And there are two types of events that typically happen: dependent events, which are events that affect one another, and then independent events, which are events that don't affect one another. Today we're going to primarily talk about the counting principle, which states that if there are A specific ways for one activity to happen and B specific ways for another activity to happen, then the number of total ways for those events to be combined is A times B. We're going to look at some classic type problems. Let's take a look at this one specifically. It says Joe needs to buy a suit and a tie, and the suit comes in a choice of either black or blue and is made from either silk or wool, and the tie is either solid or striped, and we want to know how many different selections can be made. Well, we actually have three events here, and none of those events depend on one another. For instance, if I pick a black suit, it has nothing to do with whether that suit is made of wool or silk. So these are all independent events. And since I have three events, in the first, which is the color, I have two choices. The second, which is the, I guess let's call it the blend of suit, I have two choices for that. And in the third, I have the ties, and I have a style choice of two. So using that counting principle, I should have 8 total ways to pick a suit. Now, classically, I mean, when you probably had this possibly in maybe 6th or 7th grade, we make what's called a tree diagram, where we start off with a specific set of choices from our problem. So I'm going to start with the blend. So I could go either silk or wool with the suit. And from that choice of, let's say I make a choice of getting a silk suit, well, from that I could basically decide to go blue or black off a silk tie. Likewise, if I chose wool, I could go blue or black. Now, assuming that I had a silk suit that was black, I could choose one of two ties. I could choose solid or striped. And if I chose a black suit that was silk, I could have a solid or a striped tie. Likewise, if it was wool and black, I could have a solid or striped. And if it was black, I could have a solid or a striped tie. So if you'll notice, at the end of each of these, what we call the branches of the tree, I have 1, 2, 3, 4, 5, 6, 7, 8 limbs off that, if you will. And each of these limbs is a set of the choices that I have. So this is a silk suit that's blue with a striped tie. And this actually lists all the possible combinations I could use to put together. Obviously, this is a bit limiting in that it would take forever, and the more choices you have, the bigger the tree diagram, but you'd be able to see all the possible choices. So, let's do another problem. All right, we have 6 spaces in a license plate, and it can be made by taking the first 3 spaces and making those letters, and the last 3 spaces, and making those numbers, I believe. Yes. So what we want to do is we want to list the possibilities for each space, and once we're done, we multiply all those together and we get the total number of combinations. Now, it doesn't say anything in here about letters being able to be repeated or numbers being able to repeat it. So we can assume that if they're not saying nothing can be repeated, we can repeat anything we want. So I need to make a choice from all the letters in the alphabet for this first number. So I believe I have 26 letters in the alphabet, and I can choose any 26 for my first 3 spaces. Then in the last 3 spaces, I've got to choose a number. Well, I have a total of 10 numbers if I include 0. And it didn't say I couldn't repeat them, so for each of these, I have 10 choices. So if I want the total number of license plates that can be made, that's just 26 cubed times 10 cubed, which is some monstrous number. So now we've got Steve who's going to fish. He's got 5 different poles, 4 types of lines, and 43 lures, and you want to know how many different setups he's got. Pretty straightforward. There's 3 different events going on. 5 for the first event, 4 different ways to do the second event, and 43 to do the third event. So this is just, what, 860, I believe? Right there, if I multiply those all together. This one's a little bit different. We want to toss a coin 5 times, and how many different arrangements of heads and tails can be made. Well, let's think about tossing a coin 1 time. There are a total of 2 possibilities from that. If I toss the coin a second time, there's another 2 possibilities. A third time, a fourth time, and a fifth time. So if I multiply all those together, I get 2 to the 5th, or 32 different coin tosses that I can have in that case. We're going to leave it at that today. And here are some questions I'd like you to answer. And we'll move on tomorrow.